Good morning, everybody. Thank you for being here this morning. I'm very excited to be here today. Following Beth, I'll try to weave in some of what she said, which was very insightful and cerebral, and try to build on top of that in some ways with a slightly different perspective. So what I'm going to talk today for the next few minutes, and I'll try not to stand between you and coffee right after, is about the challenges that enterprises are facing today with large amounts of data and the demand for real-time processing and what that does in terms of strain on enterprise architectures. But first, let's step back a little bit and get some perspective on how we got here. Beth earlier talked about the Industrial Revolution and how it started from 300 some years ago and so on. I'll take it a little bit more recent. What happened is when Thomas Friedman and Nandan Nilekani, the co-founder of Infosys, talked about the world being flat, they were really referring to globalization and the impact of what was happening with the world around labor, around goods and services, and the impact of that on the global supply chain. What they did not quite have in mind, or maybe they did, they just never brought it up, was the fact that even the nature of data was being impacted. And the way data became relevant, or what data became relevant, also got impacted. And what we saw was that data moved, or the definition of data, or relevant data, moved from what was application silos to beyond application silos, across applications, to the four walls of an enterprise between data systems and applications. And then eventually, as globalization happened, data sort of went past the four walls of an enterprise and became global. And the impact of data across the globe was happening to enterprises all over the world. The other thing that happened was the culmination of a bunch of technologies that came together right about sort of at the same time and feeding into each other. And what was happening is that led to an explosive growth in data. So as compute capacity increased and improved, what happened is we were able to process AI workloads a lot faster. With network bandwidths and network speeds increasing, a lot more data could move around very easily. And this was needed. Why? Because, as we heard earlier, massive amounts of data is being collected and being generated. Everything from social media, your Alexa listening to you. In fact, I'll stop right here for a second. We have this joke in our family. My daughters will say something to Alexa, and just about a few minutes later, you'll have an ad on your emails, on your mobile devices about what you were talking. So they'll say something, like, yeah, I really want to watch this movie, and you'll have an ad from Amazon Prime saying that there's a movie available for you to watch and so on. And it does happen. It really does happen. We've tried it many times. So between what was happening with social media and the friends here on social media and all sorts of devices and sensors springing up all over the place, there was this perfect storm and a rising tide of data generation and data processing that was needed. And it was all sort of feeding into each other. Now, why is this important? The reason this is important is because as globalization happened, any event happening anywhere in the world was impacting anybody and everybody across the world. So whether it was a political event, an environmental event, a social event, an economical event, it impacted every enterprise everywhere in the world. Humans as well, of course. So if you look at an example of the tsunami that happened in Japan, the conflict in the Middle East or Eastern Europe, a country announcing their GDP numbers, any of these kinds of events would lead to somebody getting impacted. And the time window of the impact was very different. So if you're an investment bank and China announces their GDP numbers and they're not as good as they should have been, you want to sell. You want to sell before somebody else sells. And if you can't process that event quickly enough, guess what? They sell before you do, and you lose out. And that's why enterprises had to process these events, and they had to process these events right away. And then with all of these technologies coming together, more data was being generated, and more data needed processing. So I read a statistic. I know Beth was saying that there's not enough data very soon because you need a lot of learning to happen to really have your AI systems to become smart. But believe it or not, the amount of data that has been generated in the last 3.5 years, in this decade, has been more than the amount of data generated in eternity before that. Let me say that again. in the 3.5 years now is more than what has been done in eternity before that. We have, I don't know how many, 3,500, 4,000 times the data that's in the Library of Congress that is floating around today. And it's all because of what's happening with technology here, and all because of the need and the demand from people to be able to do everything in real time. Nobody wants to wait for anything, binge watching or wanting to be able to walk into a restaurant and have them know exactly what you want to do, or walk into a store and them knowing what you like, what you don't like. All of these things are commonplace today. Let's look at an example. I talked about a bank wanting to process information quickly. Let's look at an example of a bank. So if you're looking at a trade that has to be executed by an investment bank, how do you start? You have to do some pre-processing. You have to price your asset first, right? So to price your asset that you have to execute against, you have to do some pre-processing. You have to collect some market data. You have to collect the latest information and prices of all of your different assets in your portfolio. You have to run some what-if scenarios on that. You have to run some risk calculations. You have to do one of your Greeks and so on. And once you do all of that and you come up with a price for your asset, then you execute the trade. Once the trade is executed, what happens after is a lot of the settlement stuff. So, the processing of the trade happens, the settlement happens. What you're looking at is, exchange of the asset, the registration of the asset. All of that happens. Once that post-trade processing is done, the next step then that the investment banker has to do is make sure that the risk profile of that portfolio hasn't changed. So what they have to go back and look at is between the pricing of the asset and the execution of the trade, in those half a millisecond, 2 milliseconds, things may have changed. So they have to recollect all of that information. All of the market feeds in real time are coming in. They recalculate all the risk. They look at the portfolio. They look at the customer profile, their intent on what they wanted to do with their portfolio, pull that all together and recompute risk, and then define what strategies they have to then implement to be able to manage that risk. So if you went too far in one direction, how do you hedge against that and do something different so the portfolio profile is still maintained? All of that has to happen, and then there is the regulatory reporting that has to be done. So that's all of the stuff that's going on in that one trade that you process. You buy and sell a stock, you exchange, buy currency, whatever. This is all that happens behind the scenes. And if you break this down or you go one level deeper, what you realize is that you are in that one event of executing a trade. You're processing a lot of events and a lot of data that's coming in, streaming in. So you're processing data in motion. You're embellishing that data from historical context. You're looking at the customer profile, the portfolio profile, what is their preferences, what do they want the portfolio balance to look like, and so on. What do you as the investment banker want to do with your risk, and so on. So you have to apply a lot of historical data and pull context from that historical data, apply that to that event of the trade being processed. And on top of that, you then have to execute whatever mathematical models you want to execute to be able to make a decision. So all of this has to be done, and all has to be done in real time. And this is what is this multidimensional nature of this problem statement is what is creating complexities in your data architectures today. So what does this mean in terms of the complexity that is being created and the challenges it brings to your enterprise data ecosystems? You have latencies that come into your, and inefficiencies that come into your ecosystem. You're looking at latencies and inefficiencies caused because data is spread across a number of different silos. You have challenges with latency due to just data movement and data processing as data moves across your data ecosystem. You have challenges around executing high-performance compute on top of the data, all in real time. While you're doing that, you have to manage all the scale and all of the data that's coming in and be able to grow with that growing demand. And if a country releases their GDP numbers and they're not good and everybody's wanting to sell, that will spike up the volumes in processing. Or if Amazon releases their earnings and it's doing well, a bunch of people want to buy their stock and 3 of their competitors' stock as well, because the whole domain or the whole market is moving up, right? So that's kind of what happens, and those are the kinds of problems enterprises are trying to address, or they're running into as they process data. The problems they run into is they have technologies out there that can address 1 or 2 of these problems at a time. But what's missing is the ability to be able to address all of these problems simultaneously. So what is needed is to be, for enterprises, is to put all of these problems together, all of these inefficiencies, and address them together into a single unified solution. And that's where a unified real-time platform comes into picture. What it does is it combines your streaming data, your transactional data, your data in motion with your data at rest, with your compute capabilities and the ability to execute mathematical models and AI, all together, all in a single platform, all in real time with ultra-low latencies. Let me look at another example, or let me try to use another example to explain this a little bit. We've all been talking about AI, so I'll use that as an example. Let's say you want to make a well-informed decision. Let's start with that goal of being able to make a well-informed decision. To make a well-informed decision, you need information. You need all of the things we talked about, the streaming data, the transactional data, data sitting in your enterprise data ecosystem, which is more than just the four walls of your enterprise. It's data coming from all over the place as well. So you have a bunch of sources of data, a bunch of systems of record. And what you have to do is you have to be able to extract information, relevant information, and be able to put it together to be able to make a well-informed decision. If you don't have relevant information, you'll have biases, you'll have incorrect answers, you'll have inaccurate decisions that you make, all because the data was inaccurate. So what do you start with? You start with perhaps putting a data hub on top of all of your different data sources. What does a data hub do? It provides you with a single place, a single, maybe more efficient place to be able to access all the relevant data that you need to be able to feed into that decision-making engine. So this data hub will be able to read and write from all of your different sources, both directional, bidirectional communication, and becomes that single point of information for your decision engine to be able to process it. Now, this still has some challenges. What do you do when you have your event stream coming in? You go to your data hub, you pull out the relevant information, you embellish that event stream with whatever stream processing that you have to do. Let's say you extract certain features out of that data, you extract and generate your vector embeddings. You write that to an AI data store, make it available. Why? Because you want to be able to run your AI models on top of it. And if you just look at all of this, this picture here, you have your streaming events coming in, you have your stream processing, you're pulling context and historical data from your systems of records and your data hub. You are extracting features, you're generating vector embeddings, you're writing them back to your AI data stores. Then you're pulling all of this information back and pushing it into your execution engine to be able to execute your AI models. So just in the time it took me to say all of this, of course, a machine does a lot faster than I'm talking, but still, data going into a system, pulling out of the system, being processed, being written back into a system. There's a lot of back and forth with large amounts of data that we are moving, and that causes latency. So even though we had a data hub, a single place to go access data, just reading and writing data multiple times causes latency. And one of the problems we talked about earlier around being able to access data and being able to eliminate that latency of moving data across silos is still here in the system. So let's see, what do? We try to combine all of this data processing into a single platform. We build a compute grid, we push all of the processing into the compute grid. What does that do? It allows us to process things, parallelize the execution of all of the processing. It also allows us to scale horizontally. If workloads increase, demands increase, you can just add more capacity and scale horizontally. So that helps you a little bit. That helps eliminate that one problem of scale and one problem of compute processing. You still have other problems with network latency and disk I/O and so on as you go back and forth with your data hub. So what do you do next? You take your data hub, you put it together. Maybe you put it on a low latency cache. You have a backing persistent store there as well to be able to make your data more durable and resilient and so on. And now you have your compute engine going against your low latency cache to be able to access data. What does the cache do? It eliminates your disk I/O. It eliminates the time it takes for you to read data. It still has a little bit of a problem here, though. You're still going over the network, pulling data out from your cache, taking it in, processing it, pushing it back. So that latency, because of the network, is still there. And there's only so much you can do with laws of physics. Network latency is network latency. That's not going away. I mean, you have bigger bandwidth and bigger pipes and so on, but there is some latency in the network. So how do you eliminate that? Well, if you could put a bow around all of this and combine all of this into a single platform where you have your data store, your data cache, low latency data store, and combine that with computing on top of it, that eliminates that or minimizes that network latency as well. So instead of moving your data over the network to where your compute is, you can move your compute to where your data is. Think of it, going back to the 80s and 90s when you had stored procedures. It's kind of doing the same thing, but doing it in a far more efficient way, in a far more scalable way. It's interesting, you go back to those good old days about things, and you try to make those things better. But that's really all we're talking about here, is being able to move the compute to where the data is, as opposed to moving massive amounts of data for your AI models over the network into someplace else. So that's kind of what we're talking about here. This is what collapses your data processing into a platform that eliminates all of those different kinds of latencies that we talk about. So a very quick plug on GridGain, otherwise I'm not allowed to go off the stage. I have my team sitting back there making sure I do talk about it. So very quickly, what does GridGain do? GridGain is that unified real-time data platform that simplifies your architecture in a very non-intrusive way. It supports stream processing, transactional processing, analytical processing, behaves like a data hub, allowing you to accelerate your enterprise applications, your BI, your reporting, your data pipelines, your AI workloads, whatever. It also behaves like a system of record, fully asset compliant with durability, snapshots, backups, point-in-time recovery, all sorts of fun stuff, and allows you to be able to execute those AI workloads far more efficiently. I won't go into much more detail on GridGain. We have a booth outside. If you're interested, we can talk more. But I want to point out this one more thing here. What a technology like this, or what this consolidation of these data processing elements do, is that if you look at your traditional enterprise architecture, when you move from one end where you have data coming in and you go through all of these different silos, all the way to extracting value out of that one event, that one data element, as it flows. Remember, data is flowing and it's not static, right? So as it flows through your data ecosystem, it's going through boundaries and hops and silos and so on. And that causes inefficiencies in your data ecosystem. It also causes problems with data security, data integrity, data consistency, and so on, and creates an architecture that's very unwieldy and difficult to manage. If you consolidate some of it, I'm not saying you put this all together into one big bulky thing, but you can consolidate some of it to limit the number of hops you have to go through, to limit the number of silos you have to move your data through, and to create just a little bit more efficiency in your data ecosystem to help you process those AI workloads at a pace, at a speed that is relevant for what you want to be able to do with your business. So key takeaways here: enterprises do need something where they have to process data in real time. That's what the customers are demanding. That's what the market is demanding. And the way to do that is to be able to combine your stream processing, your event processing with compute capability, so that you can do all of that together into a single platform and eliminate a bunch of those latencies. And that's what a unified real-time platform provides. With that, thank you very much. I appreciate your time, and enjoy the rest of your conference, and safe travels.
Well, thank you.